Hey guys, we are in 10.4 in your Algebra 2 book, and today we're going to be learning about using addition with probability. Now, before we get too far into that, I just wanted to kind of go over a basic concept with you. And I want to talk about Venn diagrams, because you're going to see some Venn diagrams in your homework or in your book. So before we talk about probability, which is kind of its own thing, we're going to look at some Venn diagram problems to kind of help get your thinking about this word or, which is a really important word. Or. Okay, so let's look at two different scenarios, and we're also going to add a couple definitions as we go here. So here's the first one. A group of science students have a choice of visiting either a planetarium or an aquarium on a field trip. 30 students went to the planetarium, 25 went to the aquarium. How many students went to either the planetarium or the aquarium? Now, this is a pretty easy question, but we got to start easy because we're going to build on it here. So we got to kind of have a baseline. So if we were to make a Venn diagram of this, we would have two groups, two circles, okay? And then we'd have the planetarium and we'd have the aquarium people. Now, an important idea to pull out of this, if you're thinking about a field trip going to two different places, you can't really go to both at the same time. So there's not going to be any students who are going to go to both. So when I represent these with like a Venn diagram, there's no overlap here because you can't have somebody go to the planetarium and the aquarium at the same time. They're either going to go to one or the other. So what we have here is we have 30 students going to the planetarium and we have 25 students going to the aquarium, and there's no overlap here. And so if we want the number of students who go to either one or the other, we're just going to add these together. Which is going to give us 55. Okay, 55 students total. So that's pretty basic. That's not super, mind-blowing. But there's an important word here that we need, an important definition. And the term here is mutually exclusive. Okay, mutually exclusive means that there's no overlap. There's nobody that can be in both groups at the same time. Okay, so these Venn diagrams, they don't overlap, they're completely separate. We call that mutually exclusive. You might, at some point in your math career, see this as disjoint. Okay, so these two things can't happen at the same time. All right, now again, that's pretty basic. Let's talk about when they do overlap, though. Okay, so let's look at this next scenario. We have 30 students in chess club, 25 students in student council, and 5 students in both. How many students are either in chess club or in student council? Okay, so what we got here is we got some overlap. Okay, so it looks a little bit different. We got chess club and we got student council. Okay, now to represent the numbers in each of these, there's a couple different things we have to keep in mind. So first of all, there's 30 people in this chess circle, right? 30 total, but 5 people are in both chess and student council. And so what we put in this section here is how many students who are only in chess and not in student council. Well, since there's 30 students in chess club and there's 5 students in both chess and student council, that means there has to be 25 students in just chess club, but not in student council. So you can see that now there's a total of 30 people in chess club, right? Okay. Let's look at the other side, the student council students. Now there should be 25 people in this circle, right, total, to represent all the people in student council. But 5 of them are in both chess club and student council. So what we're going to do is we're going to put a 20 here so that we have a total of 25, but 20 of these student council students are not in both student council and chess club. Okay? So this is all the students that are in chess club only, this is all the students that are in student council only, and this is all the people that are in both. Okay? So you can kind of, if you wanted to, you could kind of, write down here, well, this guy's 30, right? And then this guy's here is 25. So if we want to find out the number of students who are in one or the other, now our definition of or means they can also be in both. So there's an exclusive definition of or that says it's either here or here but not in the middle. This is going to be like an inclusive definition of or. So if they're one or the other, or both, that counts. So basically we're talking about how many students are we talking about? 35 students in chess club, 25 students in student council, and 5 in both. How many students are there, basically? So what we would do here is we would have to take this number, 30, right? And we would have to add it to this number, 25. But then if we do that, we're double counting these kids, right? Because there's 5 in here, and the same 5 that are in here are also in here, those ones that double overlap. So what we do is we have to subtract the overlap, right? So we have the total in the first circle plus the total in the second circle minus the overlap. That's going to give us 50. There's 50 students here. So there's actually less students here than there is here, because these are disjoint, right, or mutually exclusive, so you just add them together. Here, you have to take into account that you can't double count these. Another way to think about it is you have 25 plus 5 plus 20, right? We don't want to add this 5 in twice, so 25 plus 5 is 30, plus this 20, that's 50 total. Okay, so if you don't do this, what happens is you're double counting that 5. You basically have 25 plus 5 for the 30, and you have 5 plus 20 for this 25, right? If you didn't have this, what you're doing is you're adding those same 5 kids in twice, and that's why we need to minus one of those 5s out so that we're only adding those 5 in one time. Okay? So the word for this, when there's overlap, is inclusive. Okay? So these are 2 key terms that you're going to need to know when we talk about probabilities. So probabilities, you have to determine how many ways there are for something to happen, right? When you do probability, you have to know how many ways to get this outcome out of how many total possibilities there are. And so this is not a probability problem, but this is a way of thinking, well, how many different possibilities are there? You know, how many different students are there? So it's kind of a counting problem. So key concepts are mutually exclusive and inclusive, and notice the difference here. This here, if they're mutually exclusive, you just add the numbers in the different groups and you get the total. Here, if you want the total, you have to add the 2 numbers in the different groups and subtract whatever the overlap is or whatever's in both groups so that you can not double count some. Okay, so we got group 1 plus group 2 minus overlap. Okay, and this is just group 1 plus group 2. In the next video, we're going to put that into place with some probabilities and talk about those same ideas.